Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on Kano script. Alright, so the last thing that I did relating to this was writing rule 110 in the language, right? And I did that in a recording, so it's going to go up on YouTube later today. So nobody has seen it yet, but I can show sort of what the result of that is. So it's in here. Rule 110.kano. So, yeah, it's kind of messy because it has to be. Because it doesn't really work otherwise. But yeah, we have series of if-else's and things like that. And if I take this rule 110 and I put it into the build, then I can build it. And there we go. That is the output. Yeah, and it is faster than the Python that was in here as well. So that is pretty cool. Pretty cool. Because I wrote the equivalent thing in Python. Okay. Yeah, but you can like adjust it if you want to as well. You want it, so this is sort of the controlling level. So I'm gonna make it say 64, right? Then it will be larger. So that's pretty cool. I'm gonna remove a couple of things here. There we go. Now it's a lot cleaner, right? So yeah, today there's not really any specific goal. Just kind of cleaning things up, right? Actually, I'm gonna put that rule 110 back because there's a very important thing relating to that I would like to fix. So this, right? This is the iteration variable that controls this, right? The control variable, whatever you call it. It doesn't work if we move it down here. So if I just grab hold of that right there, put it. Okay, I guess I gotta put it if I can just do that, right? If I do this, then it's segfaults. So it's for some reason grabbing the wrong variable or something, something like that. So I would like that not to happen, obviously. So that's one of the things I don't want to fix today. So let me go ahead and go into the source, and something that might make this easier is genexpr, right? We do genexpr. Well, actually, let's do var declaration, right? When we declare the variable, let's put the variable name in here as well. You print var node value dot var dot name, and put it down here as well. Which I have two of the exact same code, so I do need to fix that up. Maybe today. View arg, and it's the same thing. So node value dot var dot name. Okay, so if I do that and then I build it, I should be able to see all the stuff that's going on, right? So run this. And then if I look at the rule 110.tasm, it should say, oh yeah, so this is the variable that we're declaring here. We should have var declaration I. Yeah, so okay. So it's supposed to allocate at the top, but it does not. So that gives me an idea of where it's at. Let me see, iterate. Do we have iterate? Yeah, so it's all the way down here, 612. So that is not right. So it thinks it's in a function, right? So it's trying to grab it incorrectly. It's actually to do with the parsing, right? Parse. So, right, if block stack count equals 0, so it should equal 0 at this point, but it does not. So, actually, let me go to the end. Kind of a long switch statement, but that's alright. Block stack. Do I decrement the block stack? I should. Alright, it looks like we don't anywhere. And that, I'm gonna go to end. We have that. We decrement the labels, so maybe we should check the labels instead. The label scan, because that's like an equivalent thing. Right, we could do that. So yeah, maybe I will try that. Yeah. Instead of that, so var dec. Well, yeah, parse variable declaration, and we can do if labels, right? So where are the labels? Yeah. Hello everyone. How are you guys doing? What is up? And what is that? It's a dot. Okay. Yeah, so it's still cycle fault. So that is yeah, okay, so that didn't change anything. And I really did not expect it to, but let's go back to this. So I need to decrement the block stack. So maybe I will print out the value of it. Block stack count, right? Trying to make a GTK3 app. Nice. Have you used GTK before, or is this your first time with it? We have. Okay, I'll just try that. So then I can see what the value of it is. Okay, 001. Yeah, so I need to decrement it. That is clear. Yes. So let's go to N, and we'll just decrement the block stack in this case. So why don't I do that? Hey yo, how you doing? First time. All right. So what is the app? Is it something you told me about already? If stack that count equals 0, then print there. It's the same one, really. So for block stack. Yeah. Port of an old tool for X-render. Okay. Tool for configuring monitors, but rewritten in GTK3. Alright. Alright, nice. So how is GTK so far? You could actually just finish your internship this morning. Implemented an integration between two systems. Seems to be working pretty good. No one called to complain about it. That is good. Right, okay. No, this needs to be equal 0. Yeah, then it's still seg false though. So we don't have enough n blocks. Okay, it's fine, but need to get used to it. libxrender is annoying. Okay. I miss an n here. No, indeed. And what is this n for? That is for the while loop, and then we have the n for the function. All right, let me print what the value of the block stack is, perhaps as well. Right, like the type, which I guess I can't really do that yet. Let me think. So I print out that. So block stack. Data block stack minus 1. But that could be not good. So maybe I don't want to do that. Okay. Yeah, so it's supposed to be 0 though, because we're not in a function or anything like that. Let me declare this here. What if I put it at the end, right? Well, actually, hang on. So like then. Yeah, it should only be an end that closes it. So, but the else. Yeah, okay. We don't use an else, actually. That's not even it. Yeah, we don't here. So we do with if, else, and while. Because this is the label, so that's something different. So why is it getting incremented more than once? Right, and with the function as well, we push 1. So yeah, maybe I will try out GDB. And actually I forgot to break, so shoot, that's gonna be messed up if I do that. I need to not fit it out. Close off the GDB interface. Okay. Enable and I'll break in parse. Run with rule 110. Uh-huh. So then let's go through and see. Okay, so here, and let me display. Yeah, it's 0 right now. We don't have anything for any of these. Yeah, it's hiding. They're fine. These are the global variables that we declared. That's what all of those are. Okay. Then, yeah. Struct. So it's declaring a struct. That's not going to increase it either. Okay, so what is that? So this is the function. So can I print the node value of deck name? So yeah, okay, that is the string compare function. That is fine. And then we should have an end once we get to the end of the function. And so here, this is variables that are in the function, so that is fine. Then we have wall, so that pushes another one. Okay, and then an if that pushes another. So let me actually look at that. That's not right. So then if that end, yeah, so we have enough ends for all of these. So 1, 2, 3 ends, and we have 1, 1, 2, 3 opening ones. That should be okay. Okay, then we have the then that doesn't apply to the block stack. Then we have that. Okay. Then we have the ends. That's gonna decrement it. Where we find zero documentation about libxrandr. Do not look into the xrandr tool source code though in order to get any information. Really. xrandr. So this is just a way to programmatically interface with xrandr, right? Code base. Is this the right tool? I'm assuming so. You could read the source code. Yeah, that's unfortunate when things do not have enough documentation though. Okay, decrement that, and then you should do it one more time after the return. Yeah, okay, then we're back at 0, so that's good. Alright, so where are we at? So we're at the end of this function now. So now it's going to increment again here, and then again for this one, then again for this one. We do have an else. Okay, so that should be, that's probably where it's breaking, right? Because we increase, when we encounter the else, we have to, yeah, we have to decrement it as well. So, at this. Yeah. Stack. 0. So same thing here, yeah. Then we do block stack. Alright, so I can try that. Okay, then it actually works. Alright, so that I think fixed the issue, hopefully. Yeah, so the issue, yeah, was with the else. Because yeah, because it wasn't closing the block, and then it was thinking that it was still in the in one of the blocks. And yeah, that probably broke some logic as well. But now we can declare these wherever. That is good, that is good. Good indeed. So nice. Alright. So I will commit that and fix issue with block stack. Causing global variables to the scope. Okay. 65 insertions, right? Okay. Yeah, okay, there's no print statements and stuff, so that is good. Okay. Do I check also that it is with an else? Because we append the else to the block stack, but then we don't check. So for block stack data block stack count minus 1 equals, or does not equal block if. Hey Alavaz, how you doing? What is up? Oh yeah, and then this is dot type, that is. Yes, okay, and then run that, and if they don't work. So, why is that? Oh shoot, because we append this one. So let's do that after. There we go. Okay, yeah. So then we should be able to do something like wall 0, then else. Okay, so that shouldn't work then. Which do we want wall else? I don't think so. Maybe. Well, probably not. Yes, that shouldn't work. Yeah, okay. But then if I make this an if, oops, I fell out. Does my favorite Vim command works on Kano? Yes, should work. Wait, do you want to teach me memory handle? What do you mean? There we go, that works. Alright, yeah, so that's good. Project in Zig, okay. Let's check for okay. Lost in the memory handling part. Alright, well I don't know how memory handling works in SIG exactly, because I've never used it. Yeah. Well, if you it's similar to C. Okay. Okay. Big memory handling, memory management. Whatever you want to call it. Yeah, I'll put manage. And let's see examples. Yeah. Allocator. Is this where you're using the standard mem allocator? Okay, yeah. Yes. Yeah, well, I'm not, so what are you confused about exactly? Like this, it's allocating U8, so that would be 1 byte, 100, so 100 of them. And then this, the defer, that's just going to free it at the end of the function. Oh yeah, most of the time it's just, you have to allocate enough space for the array. Yeah, just like that. Return an array list that is allocated. Alright, well then you don't want to free it. You don't want to do the defer free in this case. If you're gonna return it, right? Here I can sort of show, right? Make a test. Right, so I'm gonna write in C because that's but basically malloc is the equivalent of this allocator.alloc, and then free is equivalent to allocator.free, right? So when you're writing it in Zig, you can allocate an array, right? So you alloc 32, right? times size of U8, right? So that's just an example, right? I'm assuming you can figure those parts out. And then when you free the array, it can't be used anymore, right? Basically. But you can, before that, you can do whatever you want with it. So as long as it's within the boundaries. So this would be 32. So you can't allocate more than 32 elements. We could do array 12 equals U8. I'm just going to do that, even though it's not actually valid C, but U8 30, right? Something like that. But you want to free it. Yeah, don't reference free memory. That's the important thing, right? So if you are returning it from a function, so let's make a function here. And this stuff is in there. Whoops, I can't actually do that. So go back. Yes, so if you have a function here, and you're going to return the array, you don't want to defer free or free at any point in this function, right? We're going to return the array, so when you call this, you'll have a new array equals func, right? And what this returns is what this array will get set to. And then you can free it sometime after this. So whenever you're done using it is when you want to free it, basically, is how it works. And defer just basically frees at the end of the function scope, right? So say you have a function here, right, main function or whatever, and you have the array in here that you're using. It's allocated and stuff. And you do stuff here with it. Array 1, array 2, stuff like that. Then you want to, and you're done using it at the end of this function, that's when you want to defer. If that makes any sense. Because you don't want to free it in this function where it's allocated if you're going to use it after it. Okay, good. So, yeah, this looks interesting now. I think there's also other types of allocators as well in Zig, right? Yeah, Zig has some interesting stuff. Lexer parser? Yeah. It was for that. Okay. Right. Yeah. Quick slur. You might be able to, let's see. Is it, okay. Go back. In the Lexer, is that what you're returning it from there? Is that what you mean? You're returning this? Or is it from in a different location? Yes, okay. Yeah, so here you allocate it looks like. Okay, let's see, how does this work? And then, yes, you want to return it. So you don't want to free it in here. Then you receive it in the parts. Yeah. So, oh, let's. This is work. Okay. What part is it? Just in the. On parts. What is this? Where you, okay, you pass it in here like that. Hang on. No. Go in here. Right here. Comes from here. Alright. Favorite string array. I like 3 times size of character times 10. Okay. Let's see. So what do you call it? So you call, alright, tokens. Alright, so you do that. And then, alright. Whoops. So if you're not using the tokens, hang on. Yeah, so you pass the tokens in there. So then you could free them here if you want it after this. Assuming you're not using it after that. Yeah, because you get the AST from the parser. And then unless you're using the token somewhere in the AST, you could free it right after this. why did you stop using Rust? Well, I haven't stopped using it entirely. Like I use it sometimes, but I like using C better, so that's primarily what I do. What I'm using. Yeah. Okay. So let's see. I would like to fix something here. My malloc char to make a string. I heard I should add another place for null terminator. Yeah. So you need an extra, like if you allocate a string, story, yeah, right? It's side the character, which just one. You don't technically have to do that. Times 8, right? And then you have 1, 2, 3, 4, 1, 2, 3, 4. Right, so that'd be 8. And then there's also this that gets inserted at the end, so you do want to allocate for that. Just like that. Yes, that is correct. So maybe I could even do some stuff with this. Make the keywords and then the built-in keywords. Should I do that? Doesn't segfault though? Well, it could segfault. That's the thing. It doesn't always, but if it is still touching the memory in the wrong place. So like if you run it using Valgrind or something, it's probably gonna tell you. Like if you are accessing it, like if you pass it to a function like stirlen or whatever, and it doesn't have the null termination at the end, it might work. Because it might be like a null at the end of it. Sometimes that happens in the garbage data, but sometimes it might not be. You know. So yeah. So it's not just bad practice; it could cause a segfault. Usually, though, segfaults happen when you are going way out of bounds. You know, like they can happen less than that, but it's not necessarily always going to be the case. But yeah, a good way to check for that is running Valgrind on your tool or your program, and then that shows, like it's not perfect or whatever, but it can show a lot of the memory problems that you may be having. Yes, like this could be a for loop over an array. And this actually has a lot of repetition, so I could do some stuff with that. Right, like this is pretty much the same thing, right? Same thing as up here. This part at least. It just replace these. What is this? Oh, okay, yeah, you have to check that. That's actually the same thing, though. C type system? Yeah. Yeah. Oh, much better than JavaScript. That's for sure. Yeah, so this is... What's that? I do this. Yeah, okay, so I could actually do this. Because I just need to pass the character, and that could be a function. So that's probably a good idea. Just have a type system? Arguably not. C in general is great. Well, I mean, there is a reason that it's stuck around for so long, right? So yeah, let me try that. This could be a function. This part here. And that's gonna... Well, actually, we can return the word. Then it had to be allocated, though. Do I want to do that? Well, actually, it already is going to be allocated, so... Oh, yeah, TypeScript is not. Well, it's not really on its own, right? It just transpiles into JavaScript, right? Right. If I understand. So this can be, generate string, right? Generate string. Generate string. There we go. Then, I had to do this a few times. Why is it not... Oh, shoot. Actually, I know why. Serious, and then I will fix it again. Okay, actually, let's get it. Okay, and then this gets indented. This goes twice. might be, oh, hang on. Get indented one more. Okay, this, actually that's not right. Wait. We're missing one now. So this is actually in the loop. Oops. Actually need to go back one more. Because this doesn't need to be indented like that. And there we go, now it's right. Why not Python, huh? Meta, how you doing? Wait. Arch Linux Racer, I didn't notice how much Python was used for Linux customization. Python actually, like, at least it's strongly typed, unlike JavaScript, right? Let's see. So this needs to pass. You need to pass the character here, and the string view. Let's do that, perhaps, because we have to modify the view. Okay, as a pointer, and then also the character. This is the limiter, right? It's not equal to in. And then this, that's always gonna be that, so we don't need to do anything with that. And that is not right. What the heck? What the heck? Okay. It's a dereference that. So view equals that. Okay. Yeah, strong type but not safety type. Yeah. Okay. And JavaScript is basically just not typed at all, right? Okay. Hopefully that is right. So generate a string, and we're gonna pass the delivery there. Looks kind of weird with all the stars, but that's okay. Okay, let me see if that compiles. Yeah. It does not. Okay, 202. I need to reorganize that as well. And actually, I need to return the word. And actually, now I just realized that the indenting is all wrong. And that's not right. No. It's just an extra space and all of that. There we go. Talking about why not Python. Yeah, I got that. Why not Rust, though? That's not a joke. Nobody's ever said that joking. What is that? What? Escape. Shoot, I had to use, yeah, okay, that's better. I forgot that, okay, let's do that instead. Then it looks a lot nicer. That's still right. Okay, print error does not work because there's no token. What? Shoot, I need to pass the token. Okay. There we go, jumped to the wrong one. I need a pointer. And I do want to do that too. Alright, one more. Okay, and then I can call this function. So, okay, there we go. So this is stir load equals generate string, and I need to pass all of the things. So, but I need to pass the function to it, a reference, yes. And the token, and then in this case it is that. Okay, I can get rid of all this. And that should replace it. Okay, if I run this, and it still looks like it works, so that is good. And I can do the same thing here now. Very nice. Codium AI is cool. GitHub Kohi, but free. I use it for filling arrays with random data and boilerplate. Codium AI, I haven't heard of that. Codium AI. I did not know that was a thing. Okay. The website kind of bloated. New pull request AI agent. Okay. Yeah, I didn't even know this was a thing. Makes sense they can generate unsafe C code though. It's not really for that, right? This one. Oh, it's not this? Wait, are you sure? Oh, shoot. I spelled it wrong. Okay. Huh. These have the same name, not have the same purpose? Okay. I see. Alright, so it's like Copilot. Cool. My computer does not like this website for some reason. Okay. Cool. Yeah, I did not know that was a thing, so. Not right at all. There we go. And get rid of this. Perfect. Make a text, right, that actually uses a character. So, x character equals x. Let's make a string. I do that, and do this. I'll do 2 actually, and then let's call it k. And then 0 initialized, so I can just then write it. And it did work. Okay. Yeah, so those still work. Very cool. Alright, what else? What is this? This could even be a like one line, you know? Okay, that is okay. Is there anything else here? Expected closing quote. So that means it failed. That means it's like this. Yeah, okay. So what is this? I need to use an arena or something similar, different memory allocator. Because right now I just allocate it and then don't worry about it, and that's not exactly good. But yeah, so I have an arena I can use, like just a header file. That's probably a good idea, and then I can just replace this with a call to the arena. What is this? What am I doing here? Word, Why do I do that? What? Yeah, why? I just use word.data. I not do that. So I do that here in the string copy. Hang on. Okay, yeah, so I don't know what that's about. Which makes it harder to read. Okay. Token type none. Oh yeah, so if none of these are true, then it's an identifier. Yeah, I do free the word, but then I allocate a new one for the token. Makes sense. Try to do that though. Guess I probably want to. So why don't I just create a view out of that? Hang on. That's probably a good idea. I can just use the view. Yeah, and then get rid of this. And then so view ident equals just the view, and that's it. I don't have to copy anything, and I can just well, yeah, I can just set it to view instead right here. Yeah, and then it'd be allocated in the arena once I implement that. And yeah, it still works. Okay. That makes a lot more sense. Okay. This, what is this? Oh yeah, that's like decrementing it. So, okay. Yeah, these are all the same thing. That's fine. Okay, I'm gonna be right back. Break. Yeah, it's gonna be about 3 minutes. Okay, I am back. All right. So yeah, that's fine then. This though. Yeah, this has to be checked here because an operator can be part of it, so I have to check that to that. Else unexpected token. All right, so that is fine. So like, let's see, what's an unexpected? What's one that is not used? Like this is not used. That we'll say unexpected token. Yeah. Let me say what the token is though. Mm, There we go. Unexpected token that, and there's an extra new line. That's my bad. And there we go. Okay, yeah, that is good. Maybe I'll do that. There we go. I'll commit. Clean up. What is this? What is this one? Lex. Oh, what the heck? Oh. Yeah, Lex. Okay. 109. Really? I don't realize it was that much. All right. Anyway. Can you help me with the C socket API? I can't send a file through it. I don't know. Let's see. I haven't used it in a while. Uh-huh. Let's look at this. So, yeah. Reading from it. Where is... So what happens when you try to do that, or you just don't know how to do it at all? Buffer, right. So where do we write to it? Okay. Send. All right, that's where it is. That makes sense. Send that. Right, and then here you don't know. Okay. Well, what do you want to send of the file? Like, you want all the contents of the file? Because you could just like, this shows how to read it. Like, send HTML. Oh, okay. Yeah. Well, you can send the contents of it. I'm not sure if that's the way you're supposed to do it, but if you just open the file on the server and then read from it into a buffer, right, a string, and then you just send all those contents and then accept on the server. The same way you do this, you know, like you can use fopen and fread and such, just into a buffer like this, and then you also need the length of it, but you can get that from reading the file. When you read it, you get that, and then just send that. I don't know if that's how you're supposed to do it though, because I've not really written a web server in C. That sends it, and this is the buffer that it's reading into. So you do want to make sure you have enough room on the buffer to receive the message. But yeah, I mean, that's that is a way you could do it. All right. Yeah, I'm not sure. HTTP server. Okay. Oh yeah, you can do this too. I don't know. I haven't done it, so you'll have to just read up on it. You know, you just look up this. There'll be some stuff there. Maybe even write server. Let's see. That might give something. Yeah, like this. This is probably a full example. Binat, okay. Yeah, so it's pretty similar because it's the same stuff, but yeah, that might be helpful. I don't know. I haven't actually done it, so. Soon I'll look to that though, because I want to write one in KanoScript, right? This language that I'm working on. So I'm going to be calling to the C socket API for that, so that could be fun. I should fix this, but I don't want to do that right now, because that's going to break a lot of things. But yeah, I would rather set the token equal to this, and then do this. Right, because then because the way we were doing before, we consume the token, and then we look at the next one, and that doesn't really make a lot of sense. Token dot lock. Okay, type. Okay, let's see, that's gonna break a lot of stuff, so I run it. Yeah, we have unexpected. Let me run it on let me run that stage, and let's do this one. Alright, so expected type that. So let's go to everywhere that I call it expect token. And so we need to expect token. So I'm going to call token consume first. So token consume, and that's going to consume the identifier. And then we do that, and we don't have to consume this one, I don't think now. Basically just moving, shifting it around. Hey, is that right? So that's going to consume the colon. Yeah, okay, so I don't think we need that. And then expect token, what else? I stopped using it because I realized it was messed up, right? Expect token. Okay, so that's going to consume, so we have to move it again. Basically, just moving that, actually. Wait, is that it? So I'm using 3 places. I'm going to be using a lot more. But okay, there we go. Now it works. Actually, that wasn't too bad then. Yeah. Okay, that's good. Not running sage. Instead, this one. Okay, yeah, that works. All right. Yeah. So now, in places where I consume the token, I could do expect token now. And that would, yeah, like right here. Maybe not right there, but here, yeah. So I could do expect token. Let's see. Yeah, I need to pass the tokens and the token type open curly. And then do I use the open curly anywhere else but here? I don't think so. So I think we're good. Yeah, okay. I don't really use structs in here, do I? Oops. Yeah, so let me modify this one and just create a struct. Oops, that's not how you do that. Int. One int. Okay, and then I'll try that. I could open for rent. Okay. Whoops. I didn't expect that. Okay, so I guess you can't just declare them like that. Why is that? Right, but that works now. Yeah, so here I do that. I can change this to expect token equal sign. Oh, this is when we are, when we're defining a struct. That's what it is. Okay. Yeah, but that's correct then. And yeah, if I put the value in here, then there we go. So that works. That works. Expect token should probably return the token type as well, or the token. Because then we could set this to expect token. Tokens and token type item. I can get rid of this. And let's see, expect token. Oops. Expect token. If I go to that function and I can just return the token. Okay, yeah, I need to define it in the header file. Okay. Yeah, that seems like it worked then. We'll get the assembly. Make sure. So we push that and we allocate it, so we're allocating it, and then we push 0 to it, and we write. Alright, so we write. What do we write here? Alright, we're pushing 12. That's interesting. Okay, so this is just the offset that we're generating, I see. Okay. Yeah, so we're writing the value of 12, so that is correct, yes. Okay. So there's other place that I was doing that. This can be expected. What? Hang on. Oh shoot, no, that's the next one that we are doing there. So that, what is this? Yes, we already know that is an identifier. Wait, hang on. Yes, we're peeking ahead, and it's a dot. So then we can assume this one should be an identifier, but I don't check that. Because we already know that's an identifier, so we don't even need to check it. Okay, yeah, because we checked it before, so that's fine. This is checked before as well, though. So, what is this? What? This is an identifier. Why is that? The dot. Okay, I'm not sure what I was thinking with that. Okay. Alright, that works. That works. So, yes, this can be expect token as well. Ident. This one as well. Expect token equal. And there we go. These variables equal. Okay. Yeah, so we don't even need to assign this to it because we're just doing that to have the location of it. Alright. And it all still works. Perfect. Perfect. So here we're consuming info. We already know what it is. Could use expect token anyway, just make sure, but and then here we do this, so we can just expect token instead. Close bracket and equal. Okay, that it did a lot of those checks. So what is this for? This is array. I can define an array. 3 equals 1, 2, 3. There we go. Okay, that works. That works. No more of those. This I'm not even checking though. That's interesting. I should probably check the value. I'll come back to that though. Alright, that's just checking that, and then yes, this is the same thing. I can just expect token instead. Do I use name token? Yeah, I do. So I need to type item. Get rid of this. This one as well. Expect token. It's open curly. Put the struct back actually. And okay, that's good. Expect token, okay. This one as well. games and don't like haha. Alright. Yeah, I don't think we do that for any of these. We do consume though, so what is this consuming? Yeah, this actually checks in there, so that's fine. This is consuming the this one, so that is okay. Okay. And the rest are this. Alright, so that is okay, that works out. Okay. Yeah. Alright, so that is better. You know, that's not how you spell. Okay, very cool. So, alright, let me look in now, in here. Because there might be a few places. I can get rid of that. Yes, we don't need that either. Generate struct value. Yeah, just getting value from it, that is okay. This probably shouldn't go in here, but it is here anyway, so. These are the types, that is okay. What else? Okay, function, okay. Yeah, so what is this? Is current fun. Okay. Right, get variable type. So this could use get variable and just return the type, right? Return get variable state name by type. You know what I'm saying? -1. Alright, yeah, and I think I'll leave that there. I think that basically handles itself. Let me modify this one and make it. No, right? Try that one, and yeah, okay. Because that's a pretty complex program, so it goes through most of the things. Yes, we're going to need -1 because that gets handled by this if it's invalid. Which it shouldn't be at this point because we should check that in the parsing. But just to make sure, that's why it's in assert. So that is good. Okay, yeah. This is a lot of the same stuff, so. Alright, and this actually is the same as this, right? This is just one. So this can be moved to the top. To the top, you know? Just like this. And then I was using spaces here, so yeah, it's not quite right. Alright, anyway. So I can do that. Because they're all going to be built-in types. Get rid of this. I still can check for this in here. Check for the number of arguments, but otherwise, yeah, then we don't need to call all these gen experts here. That should still work. I don't have this used anyway. I can actually use Alec. It does use Alec, and that is one of them. So, experimenting a bit with auto tools lately, and it's actually kind of nice. Okay, auto tools. That's like a GNU thing, right? Yeah, GNU auto tools. Auto make. Okay. Let's see. Okay. Okay. So it's for building stuff. designed to assist in making source code packages. Okay, okay, very cool. Uh-huh. Someone to CMake. Yeah, yeah, yeah. That's what I was thinking, reading that. Cool. So how does it differ from CMake? Like, what reason would you use it over CMake? Okay, that's good. What is this? That's fine. Okay. Portability, okay. So CMake's not very portable. Never really used it, so I don't know. But yeah, that makes sense. 20. Okay, okay. I see. Alright, that's pretty cool. I should look into that. Generates a configure script that checks for libraries to be installed and other things. Okay, okay. So that's like what the, like when you're building a program, sometimes you have to do, run the configure script. So is that generated from this, or is there another build tool that also does a similar thing? What is this? Yeah, exactly. Okay, okay, okay. Makes sense. What is that? Alright, that is ending the scope. That's okay. Alright, what is this? This could probably be moved into a function as well. Take a look at... Alright, alright. Oh yeah, I have it open here. Okay. Make file. And let's see, configure. Okay. Okay. Makes sense. Alright, that's pretty cool. Failed to find that. Alright, makes sense. Alright, that's cool. I like that. That kind of configure and make. Okay. Yeah, I should look into that. Yeah, I hadn't heard of that until you mentioned it. So, I think you mentioned it yesterday, right? In the Discord. What is this? Wait, what? Why do I set it global here? Oh, yeah. I know why. Because it's in the gen bars. That makes sense. Run make dist and get a tarball for release. Nice. That is good. Okay. First part. Okay. Soon I'm going to be moving KinoScript to its own repo as well. I also need to write a lot of documentation because this is all very old and out of date. Okay. Yeah, so I do have to go pretty soon, so. Yeah. Perhaps. So let's see, right. Yeah, that would be good for sure. Yeah, I'll look into it and see if I can write something up for Kano. Because we're still making that, has it like Kanoon, I guess, is how you pronounce that. for installing it, but that doesn't necessarily mean that when building it from source, we don't want to generate the makefiles from using this, right? Like, they don't conflict with each other, basically, is what I'm saying. Did input found that? All right. Yes, this is actually the same thing. Okay. Same thing as the other one. Yeah, gen expression. So this, we get the variable y. Okay. Field resize, that's similar to this. We do a lot of similar things, but gen expression. Yeah, okay, so we have to do that. Okay. Then this is indexing the array, which is actually very similar to the struct, because they're both stored in memory in a similar way. It's just structs have different sizes, right? Here's the function. I append to a lot of things. Do I need all these? Not sure. Why do I not just set it to this? Instead, you know what I'm saying? Oops. It doesn't like that. Okay, so I guess that does not work. Huh. Okay. I set a point. No, it's not. Huh. We need to create that makefile am and run autoscan and configure a C will be created. Oh, really? Okay. Alright, that's not, that is pretty easy then. Okay. Called configure scan. Is that in here? No. Okay, okay. Yeah, I'll look into it. Thank you for the recommendation. Okay. It's gonna be one line. So I'll leave it because the condition's kind of long. What else? Alright, generate the expressions, and then this is, yeah, if there is a return value, then we pop it. If that makes sense. Or no, if there is no return value, then we pop it. Because we, why is that? Oh, yeah. If we're just calling it as like a statement, then we don't want to leave the return value on the stack. That makes sense. Type return. Okay, a lot of stuff going on here. So we get the function. So we can't, yeah, it's trying to return if it's void, then that is invalid. So we do want empty returns at some point, but I'm not gonna worry about that now. Get the position. That is very confusing. Oh yeah, but we need to do +1 because it needs to be one larger. Let's see, +1 because after scope n. Okay, yeah. Generate the expression. Yeah, the position cannot be too great. Makes sense. We swap it into place. Then we do this and we reset the stack size and return. Okay. If statement is pretty simple. Alright, so elif, what if we were doing that? Would basically there would be another condition And we want to jump to that, right? Jump to the elif at the end of the if. Yeah, so I'll have to think about that. Because I would definitely like, something like if x then elif y then else end, right? So it would look like that. And that would make it a lot nicer for series of them. Okay. But that's not like technically necessary because we can do basically the same thing by doing if x then else if y then. The only problem is then you have to chain the ends like this. Yeah, and obviously that doesn't look very good, but you can do that. Okay. Okay, that's actually the end. So, yeah. So, okay. Yeah, I guess that is gonna have to be about it, because I do have to go now. I have school to get to. So, let's see, yeah. Thank you guys for watching, and I'll see you next time. Bye.